Good afternoon, students. Welcome again to our chemistry online class for this week. Today we'll be discussing solubility. The objective for the class is as follows. At the end of the class, I expect you to be able to 1. Explain the solubility of a solute in a solvent at a particular temperature. 2. To be able to describe a solubility curve or graph. 3. You should be able to discuss the usefulness of a solubility curve to the chemist or chemical industry. Solubility. What is solubility? The solubility of a solute in a solvent at a particular or a given temperature is defined as that maximum amount of the solute in moles or gram that will saturate 1 dm cube of the solvent at a particular temperature. What do we mean? That is to say, the solubility of a solvent is dependent on a temperature. The solubility of a solute in a solvent is dependent on a temperature, and it has to do with the maximum amount of a solute that will saturate a particular solvent at a particular solution. Thus, solubility of a solute in a solvent increase with increase in temperature. Therefore, mathematically, solubility can be expressed as mass times 1000. 1000 there is standing for 1 dm cube. All over, that is divided by the molar mass of the substance times the volume of the substance. We'll get to understand this formula as we go on with the class. The mass there is standing for the mass of the solute, while the molar mass is standing for the molar mass of the solute, and the volume is standing for the volume of the solvent. Note, a solution can be in the form of 1, either saturated, unsaturated, or supersaturated solution. A saturated solution is that solution which contains as much solute as it can dissolve at a particular temperature in the presence of undissolved solute particles. That is to say, a saturated solution is that solution that has taken much more solute that it can handle, and what it can no longer handle or what can no longer dissolve in the solvent will remain as a precipitate. So therefore, there is a thermal equilibrium. There is a thermal equilibrium between the dissolved solute and the undissolved solute. The dissolved solute and the undissolved solute, which means that the rate of dissolution of the solute is equal to the rate of precipitation of the solute for a saturated solution at a given temperature. Unsaturated solution, on the other hand, is that solution that contains less solute that a solvent can hold at a particular temperature. That means that the solvent can still take more solute. There is still space for solute to be dissolved. On the other hand, the supersaturated solution is that solution that contains much more solute than a solvent can hold at a particular temperature. Thus, any slight disturbance of the solution will lead to the precipitation of the solute out of the solvent. Let's take note of that. Determination of solubility. The method of determining the solubility of a given solute involves 2 stages. The first stage is you have to prepare a saturated solution of the given solute at a specified temperature. The next stage is take part of the solution that you have prepared, evaporate it to dryness, and analyze the mass of the solute and the mass of the solvent that is evaporated. How is this done? Let's consider, for example, we prepare a saturated solution of potassium triisonitrate 5 salt in water at room temperature. After preparing, we take part of that solution that was prepared. We measure the mass of part of the solution that was prepared, and the mass measure was gotten as 55.27 gram. Then we transfer the solution into an evaporated dish and evaporate it to dryness. We discovered that what was left after evaporating to dryness was 11.87 gram of the salt. Therefore, which means mass of the solvent that is evaporated is 55.27 gram minus 11.87 gram which gives us 43.40 gram of the solvent, that is of water, evaporated at room temperature. Now, if you recall relative density, that means that the 45.40 gram of water is the same thing as 43.40 cm cube of water. Now, which means 43.40 cm cube of water dissolve 11.87 gram of potassium triazonitrate 5. The molar mass of the salt is 101 gram. So therefore, inputting that figure into the solubility formula, we will have 11.8 gram of this residual salt times 1000, which is a standard solution, divided by the molar mass of potassium triazonitrate 5, 101, times the volume of water which is evaporated. That gives us 2.71 moles per dm cube. Therefore, the solubility of potassium triazonitrate 5 at room temperature is 2.71 moles per dm cube. Solubility graph or curve. A solubility curve is a database graph which helps to compare the amount of solute that will dissolve in a given amount of solvent at various temperatures. The typical solubility graph shows solid and gaseous solutes dissolved in 100 grams of water. Now, if you look at the graph in the figure below, you'll find out that the vertical axis is showing the solubility in terms of gram, which is mass of salt in 100 grams of water, while the temperature ranges between 0 and 100 degrees centigrade. Now, carefully examination of the graph, you will discover that the solubility of sodium chloride is constant with temperature. That is to say, the solubility of sodium chloride does not change. At 0 degree, the solubility of sodium chloride is a little bit above 30, and it remains as that till the end of the curve. That means sodium chloride is constant. The solubility of sodium chloride is constant with temperature. If you look at that of potassium chloride, there is a constant increase with temperature. The solubility of potassium chloride is constantly increasing with temperature. Carefully examination of the graph, we will discover for cyanosulfate at the solubility at 0 degree for cyanosulfate is 20 per 100 gram of water, and he discovered that at 20 degree the solubility between 0 degree and 30 degree, the solubility of cyanosulfate is decreasing gradually, while at 30 degrees Celsius, found out that the solubility remains constant up to 100. Now, what is the usefulness of this solubility graph? 1. It helps pharmacists to determine the amount of solid drugs that can be dissolved in a given quantity of a prescribed drug mixture. Number 2, it enables chemists, researchers, scientists to determine the most suitable solvents to be used at various temperatures for the extraction of essential chemicals from various natural sources. Number 3, it helps with the aid of the solubility curve. At a given temperature, we can easily separate out or purify a salt, which is a mixture. For this week, we have come to the end of the class. We have talked about solubility and the natures in which solution can be found, either as saturated, unsaturated, or super saturated. The class this week has helped us to answer the question, the assignment for the last class, but I am not happy. Most of you, or let me say generally, none of you submitted the assignment for last class. You are not submitting the assignment. I am not happy about that. Please, let's endeavor to submit this week's assignment to my WhatsApp number, which still remains 08034187864. The assignment is as follows. If 18.2 grams of lead 2085 salts were dissolved in 54 grams of distilled water at 50 degrees Celsius, calculate the solubility of the solute in moles per dm³. Number 2, what are solubility curves? State 2 uses of the curve. Till we meet in the next class, stay safe.